Imagine you are looking into a complex electrical circuit, a true maze of components, and you just want to know how it will behave when you connect something simple to it. How can you possibly predict its response without analyzing every single resistor and source? Thevenin resistance, often denoted as RTH, is essentially the equivalent resistance of a linear electrical circuit as seen from a specific pair of output terminals. It represents the internal resistance of that complex network when all its independent voltage sources are short-circuited and all its independent current sources are open-circuited. The core reason we calculate Thevenin resistance lies in the power of simplification. This value is a crucial component of Thevenin's theorem, which states that any linear, two-terminal electrical circuit can be replaced by an equivalent circuit consisting of a single voltage source and a single series resistor. This makes analyzing the effect of connecting different loads to a complex circuit incredibly straightforward. It is the internal resistance of this simplified model, governing how much current the equivalent source can deliver. To determine Thevenin resistance, you first identify the two terminals of interest. Then, you deactivate all independent sources in the original circuit. This means replacing all independent voltage sources with a short circuit, essentially a wire, and replacing all independent current sources with an open circuit, which is just a break in the path. Dependent sources, which relying on another voltage or current elsewhere in the circuit, are left as they are. Finally, you calculate the total equivalent resistance between those two terminals using standard series and parallel resistance combination techniques. This concept is particularly powerful in network analysis because it separates the source of the circuit, which is Thevenin voltage, from its intrinsic ability to deliver current, which is Thevenin resistance. It helps us understand the source's current limiting capabilities. For circuits containing dependent sources, a common technique for finding Thevenin resistance involves applying a test voltage or current source to the terminals and then calculating the ratio of that test source to the resulting current or voltage. This allows us to account for the more intricate behavior of dependent elements. Understanding Thevenin resistance allows you to treat entire complex subsystems as a simple, predictable component. This simplifies design, speeds up fault finding, and provides profound insight into how a circuit interacts with various loads. It turns circuit analysis from a daunting task into a manageable and elegant process, enhancing your ability to understand and design sophisticated electronic systems.